All right, let's look at example 2. Here we're going to look at a disc here and a metal plate. And we want to find the surface area. So maybe we want to spray this with some powder coating paint or something like that. And we didn't want to know what the surface area is. Then we might need to calculate that. All right. So anyways, so surface area, area of all the surfaces. All right, that's what surface area means. We have the top of this. On the back side, will look just like the top. Okay, let's call that the back. Let's call this the top. And then we have what we call the lateral faces. So this edge right here, that's all kind of lined there. That's called the lateral face. Now, this shape actually has several lateral faces. You've got this inside of these holes there, and you've got the outside edge. All right? So, that is going to come from something, think of this. This shape, by the way, is a cylinder, right? And the cylinder looks like this, right? So a cylinder has this would be the lateral face. So if we've got this shape here that's called the base, and there's a base. My base right now is empty. Hello. All right. So we've got a cylinder shape looks like this. And what shape is wrapped around a cylinder? Think of like a soup can. And so if we unfold the cylinder, we have a rectangle. So the lateral face, the outside face of a cylinder is a rectangle. Okay, see that? Okay, so we're going to need to find the lateral face, and we need to find the top and the bottom face there. All right? And then we'll need to add all those together. So here we have a formula. Well, let's think of it first before I show you the formula. All right? On a regular cylinder, if we have a plain old cylinder, we have a few shapes. We've got the tops and bottom, which are circles, of course. And so circles, we know, have an area of pi r squared. Okay. And the bottom is a circle also, and it's going to be pi r squared also. Now that rectangle that we said was kind of wrapped around the side, if we kind of unfold this like that piece of paper I just showed you, you're going to get a rectangle. And the height of that rectangle is the height of the cylinder. Okay. The distance around that cylinder, well, that's the circumference. And the circumference of a circle is 2 pi r. Okay. 2 pi r. That's how we find the circumference of a circle. So this area here of this sheet here, that this rectangle that's wrapped around, is 2 pi r times h. That's the area. So the surface area the formula that you'll find in the back of the book will look like this. Surface area of a cylinder is, we have the two circles, top and bottom. The circles are pi r squared, plus the wrapped around side 2 pi r h. Okay, and that's the formula we should see if we look at the back of the book here. Now, if you got your book handy, you might want to take that out, and we need to note this. This is the basis. Sometimes we don't need the basis, so we won't use that part of the formula. This is the lateral area, or the lateral faces. Lateral, it means around the sides. Okay? So that's the lateral area. I'd recommend you write that in your book. This 2 pi r h is something that we're going to use quite a bit there. A lot of times we're not going to use the whole formula because the shape we're looking at doesn't use the whole formula. Okay. So with that, we have our formula. Let's see how we can use it. So again, the part that we really will want here is this 2 pi r(h) because the top is not a complete circle, okay? It's got some holes drilled in it, okay? So let me take this formula and we'll kind of chop it up a little bit. We're going to need the lateral area of 2 pi r(h). That's what we're going to use there, okay? We'll call that the LA, the lateral area. All right, great. Well, let's start with this. Let's find the area of the top. Okay, so again, surface area just means you need to find all of the areas of the top and bottom and the sides and add them all up. So we can kind of piece this out. The area of the top, well, we've got a big circle. The radius of the big circle, we're told, is 38-inch diameter. So the radius is half of that, half of 38. 38 divided by 2 is 19. So this is 19 centimeters, okay? So that would be the full circle. The full circle there would have an area of pi r squared. Okay, so it would be pi times 19 squared. However, we don't want the full area. We got to cut out these little holes. And the holes have a 6 centimeter diameter. So the radius is 3. Okay, so our radius is 3 for the little hole there. So we're going to subtract those holes. So we're going to subtract the area of that small circle. And so the small circle is pi times 3 squared. But how many of those do we have? We have 5 of them. So if we take the big circle, we have pi times 19 squared minus 5 little circles. Okay, and that will give us the area of the top. You agree? I hope so. The bottom, or the back side, is going to be exactly the same. Okay, so 2 sides there, which look like a big circle minus 5 little circles. Okay. Now, let's just kind of leave that alone for now. We can go get a decimal, but we actually don't need a decimal right now. Let's just leave that alone. That's the area of the top and the bottom. Now, let's talk about our lateral area. Okay. So our lateral area is going to be all those side parts added up. Okay. So our lateral area, so this, I'll put a parentheses, lateral area, just remind us of this. Okay. That vertical stuff. Well, the lateral area formula is 2 pi r(h). That's this guy down here. Okay, this one right here. So let's talk about, well, first of all, we know the height. That's 4 centimeters thick. That's going to be our height. H is 4 centimeters. Okay, that's how thick it is. So if we want to find this area around here, all the way around this metal disc, all right, and all the way around the whole side, okay, then we need to use that formula, 2 pi r(h). So the outside there would be 2 pi, let's continue with blue, 2 pi, and the radius of the big circle is 19. And the 2 pi r(h). So 2 pi r(h). The height was 4. There we go. So that's our 2 pi r(h). Now, that's the area of the outside. But when we spray paint this, or we do some powder coating, which is a fancy way to paint metal, we've got to paint the inside of this, right? Okay, and that paint's going to go all over everything. Well, these inside ones have a radius of 3. So we have, we got to add that area. That's something we got to paint. And so that inside of this circle is going to be the same formula because it's like that wrapped around a rectangle, like around a soup can label. Okay, so 2 pi, and now the radius is 3, and the height is still 4. Now, how many of those do we have? That's just the lateral face of 1. We have 5. So we have 5 of those. All right. So what do we have? We've got the area of the top. We've got the lateral area here. Okay. Let's go and get some decimals for this. All right. And then we can put it all together. Normally, we're going to want to write one. We're going to practice writing one nice formula, but there's kind of so much going on here that we're going to need some decimals. Let's get some decimals here. So if we start with our pi times 19 squared, use the pi key when you do this. So we have pi times 19 squared. That's the area of the large one. Then we got to subtract 5 small circles. So we're going to do minus 5 times, and that was pi times 3 squared. Whoops, lost my 3. Okay, so we see one big circle minus 5 little circles. That's 992.743. 992.743. And that would be square centimeters. So that's just the top. We're going to need the top, and we're going to need the bottom. Okay, so we'll need to double that here in a minute. Okay, now the lateral area, we have 2 pi times 19 times 4. So that is 2 pi r(h) for the outside. And then we're going to subtract off, or no, we're going to add in this case, the little ones. All right. 2 times pi times 19 times 4. It's 2 pi r(h). That's the area of the outside there. And then we need to add the 5 little circles, little lateral faces, which are 2 times pi. You might notice I'm not putting a times in between the pi. The scientific calculators will usually understand that that means times. All right, I think that's all there. So 854.513. 854.513. Okay, let's find a place for that. Great, so now we need the total surface area here, and then we're done. So to find the total surface area, which we can abbreviate as SA, maybe we'll put SA total, just to kind of remember that we're now adding the whole thing. So the total surface area, we're going to have the top and the bottom, or back, I think I called it top and back, front and back, is we're going to have 2 of those. Okay, we're going to double that 992.743, and then we're going to add on all the outside area, 854.513. I'll let the calculator do the work there. So we have 2. We have 2 of these. Oops, let me get a new line here. 2 times 992.743 plus the 854.513. Gotta keep track of everything. Oops, I lost a 5 there. See that? There we go. 854. Great. So we have, we'll round this up to the nearest, what does it tell us to round to? Doesn't. Okay, but we can round, if we round the nearest 10th or 100th, these are going to become 2840. All these 9s will round up to 40. So 2840. Actually, we can say 0.0. 2840.0 square centimeters. Okay? And so that's how many square centimeters we need there. If we needed to cover this and if we needed to paint a whole bunch, then obviously we'd multiply that, all right? So we could compute how much paint or powder coating we need, whatever it is, all right? So the key here, again, is this formula right here, which you have in the back of the book. And we have it with a cylinder. We have the lateral area is just this part, and this is the circles. So we have the pi r squared for the circles, and then this part here all the way around is 2 pi r h. And so when we're dealing with real world applications, you've got to ask yourself, do I have the circles or are the circles removed? Do I have the lateral faces added or subtracted? And we got to find the parts, and then to find the surface area, we total it up. All right? So there you have it. So go ahead and practice some of those and keep it organized. Label it like on the area of the top and the lateral area and things like that. And then in the end, total it up. All right. Work hard. Have fun. Do well.